Good afternoon, everybody. I've got some practice problems for us to do together today. Seeing as how we finished the unit that we were in the middle of, right? We're done with acid and bases as a unit. I do have a couple of announcements that I want to make before we get started here. First, we're gonna move from 5 classes a week down to 3 classes a week, and I'm going to make it pretty clear what days and what times we're doing what on our Google Classroom. If you go over there, not right now, but if you go over there at some point today, you will see that I've posted what I plan to do for next week. What days and times I plan on doing things, when I plan on hosting office hours, etc. I want to remind you that you have a test wizard due this Sunday at 11:59, just like always, and that you will have one due by next Sunday at 11:59, just like always. A new thing that I want to announce is that we will have a test. Our first test is going to be on acids and bases, and only acids and bases. It's on Test Wizard. It's 21 questions on Test Wizard. You will have a timer for this, so once you open the assignment, you'll have 50 minutes to complete the assignment before it automatically submits it for you. It's a little bit longer than I would have given you in class, right? In class, you would have had about 40 minutes. Here, I'm giving you about 10 extra minutes, just because. Yeah, that's really it. So, again, 3 days a week from now on, the Google Classroom will have the schedule of what I plan to do for each of those days. And that'll be at maximum. I might do less than 3 classes a week if, that's what the pacing calls for. But we'll see what's what. Today, I wanted to get us into some practice problems. I pulled out about 25 different Regents practice problems that we're going to go through. If you get extra time for tests, I'm not quite sure how to figure that out. I'm going to try to figure that out by the end of the day today. I think I'm just going to increase your time if I can. Yeah. But again, for today, for Monday, and for Wednesday of next week, I've got a bunch of practice problems for us to go through. Again, no need for you to be on here live. If you have other classes or other things that you need to do, you can always watch these after the fact. They get posted and saved to the channel about 10 minutes after the video is over. Right, about 10 minutes past whenever I end, 15 minutes past whenever I end, it'll then post to the channel for you to watch. Yeah, pausing here for questions, comments, and concerns. I did hit 100 subscribers. I am now YouTube famous officially. That's what it means, right? Triple digits. That's the biggest YouTube star of all. Only has 120? I know that that's not true. What do I need to start making money? I need to click a button on here that says put ads in front of all my videos, but I'm not gonna do that. Alright. All things aside, we're gonna get into these practice problems. We've got for our first Regents practice problem right here. I have a copy of the reference table. I don't want the highlighter, hold on. I want the pen, I just want a different color. I have a copy of the reference table that I can pull onto the screen just to show us what we need to see. But this question, right off of a Regents exam, which volume of 0.6 molar H2SO4 exactly neutralizes 100 milliliters of 0.3 molar barium hydroxide? Alright, they're giving you a molarity. They're telling you the word neutralizes. they're giving you a volume and a molarity of a base. Right, this is going to be a problem that requires us to use our formula, MAVA equals MBVB. Right, they're giving us 3 of our 4 pieces, and we have to go and find the missing one. They have given us from the problem the volume, or not the volume, sorry, we're looking for the volume of our acid. They've given us the molarity of our acid, which is not going to be 0.6. It's actually going to be 1.2 because of this little guy right there. Right, the fact that it's H2SO4 means it's not just 0.6, it's 1.2. It's doubled. Because remember, MA is looking for the concentration of the H+. No matter how I tilt my little writing tablet here, I write at a slant. So I am aware of it. I'm just trying to figure it out. So because it's H2, it's not 0.6, it's 1.2. We're going to double it because H2SO4 is going to give us 2 H pluses. Right? They're asking me for the volume. Now I screwed it up. They're asking me for the volume of my acid, so that's going to be X. They gave us the volume of the base, which is going to be 100 milliliters, and they gave us the molarity of the base as well. Again, we need to double this number because the molarity is the concentration of the H+. Molarity of base is concentration of OH minus, and they gave me 0.3 molar barium hydroxide, which is going to give me 2 OHs for every single barium hydroxide I have. So if I have 0.3 of these, I'm going to get 0.6 OH minuses. Right? Because again, it's doubled. It's this number down here. We care about the OH, not the base as a whole. So when I plug that in, it's not going to be the 0.3 that gets plugged in. It's going to be the 0.6 that gets plugged in. When I go through and I solve this out, I'm going to get X equals 0.6 times 100 over 1.2. And when you solve that all the way out, you're going to get 50 milliliters as your answer, giving you B as the correct choice. Right? Remember, it's really important. One of the easiest ways to get tripped up in a question like this is by them giving you an acid or a base that has multiple OHs or multiple H pluses. Right? So if we go back to look at that doubling again, we talk about why these things get doubled. We're looking at MA being the concentration of the H plus. If I have 1 H2SO4, that's going to give me 2 H pluses and 1 SO4 minus. Minus 2, sorry. If I have 0.6, is like that's what they're telling me in the question, right? 0.6 H2SO4, right? With our normal balancing rules, right? With our normal balancing rules, we're going to have to double that number, right? 1, 2, 1, 0.6, 1.2, 0.6. And we care about the H+, so this is the number that then gets plugged in. Right? Going through some of the questions here. For right now, chips are suspended. I have no idea how to implement them into like remote learning. I am gonna try to think of something, but I have no idea how to do that right now. I've been focusing on just getting classes up and running, so I will think on it and figure out something. Dior, this will go onto the page afterwards, about 10 minutes after every recording finishes, right? 10 minutes after I click the end going, right? I go, right? I'm not going to say I go dead, that's not right. When I stop the stream, it takes about 10 minutes for YouTube to process the video, and then the video gets posted live to the website. So it will go live to the website. It just takes a little bit, right? A little while. Again, sorry, I'm just seeing Louisa's second comment here. We can set up a system that we use it twice as much. It really depends on what happens moving forward. I have no idea what's going to happen moving forward, so I can't really say anything about the chips until we get a little more information about when we're going back to school. Questions, comments, concerns on this first problem? All right, then moving on to our second problem of the day. Oh, sorry, Zofia asked a question about, are these the kind of problems that are going to be on the test? Yes, this is definitely going to be the kind of problems that are going to be on the test. That's the whole point of doing these. According to one acid-base theory, a base is an H plus acceptor, H plus donor, Na plus acceptor, Na plus donor. Right off the bat, you know that when we're talking about acids and bases, we're talking about either H pluses or OH minuses. So Na plus has nothing to do with this, so we can just immediately cross these ones off. Right? We know for a fact, right? We know a couple of things about acids versus bases. Right? We know that Arrhenius talks about acids saying that they are H plus producers, right? They make H plus. We know that bases are OH minus producers. Right? And that was his whole theory, is that acids are about H plus, bases are about OH minus. So OH minus producers would be a great answer, but that's not up there. So Arrhenius is not the theory that we're looking at for this question. Right? The other theory, right, our alternate theory, says that acids are H plus donors and that bases are H plus acceptors. H plus acceptor is a choice here, so that is going to be our answer for this question. All right, questions, comments, concerns there. So, moving on to our third practice problem. As we, which change in the H plus concentration represents a decrease of 1 unit on the pH scale? This is a little bit of a trickier question. Because anything dealing with changes in pH requires us to really think carefully about what's happening. They're talking about a change in the H plus ion concentration. Nope, sorry. Let's go back. That's not what I wanted to do. right? They're talking about a change in the H plus concentration, which means we're looking at 1 times 10 to the negative something, and that something is going to be our pH. Right, our shortcut for pH is the fact that if you take any concentration, right, 0.001, and you put it into scientific notation, 1 times 10 to the negative 3. That means that your pH is this value. Right, so if we want to know the pH decreased by 1, right, we want the pH to go down by 1, what effect does the concentration have on that? Right, so when we're looking at this, we want our numbers to decrease by 1. So that means, let's say, for example, we had something with a pH of 5. We want to see what kind of change turns this into a pH of 4. Right? We want the pH to decrease by 1. So I'm working backwards. That would mean my concentration is 1 times 10 to the negative 5. And here my concentration will be 1 times 10 to the negative 4. Right? And when you actually compare these numbers, the tricky part with pH, the tricky part with negative exponents, is that this number is actually 10 times bigger. It got bigger. Right, if we're going to compare these two, this is an increase of 10. Right, negative exponents get smaller the bigger they get, right? 1 times 10 to the negative, 1 times 10 to the negative 1 is 0.1, right? So the smaller number here is a bigger value. Right, which does make our answer A. Right, remember, you can think about it logically as well, right? We know that 14 is basic and 1 is acidic. So the further down we go, right, if we go down, 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 right, that's more and more and more acidic. If we want to know how the H plus affects that, right, H plus is coming from acids. If we want it to go down by 1, if we want it to get more acidic, it's going to have to be more H plus. So we know it's not going to be either of these decreases. We know it's got to have more H plus because there's more acid. And then it's about just doing the math to figure out, is it 10 or is it 100? Another reminder that every step along this scale, right, going from 7 to 6, is a change of 10 times H plus. Right, every step going from 7 to 5 is 100 times more H plus. Going from 5 to 8 is 1,000 times, right, 3 steps, 1,000 times less H plus. Right, let me just make some room here to make some notes for you. Increasing pH, right, means that we have less H plus. Right, then each step is a change of 10. if we decrease the pH, that's an increase, right? There's more H plus. So the more negative the number is, right, the bigger, right, Gloria's question here, if this is a -5, that's not as small as a -9. The bigger the number is, the smaller the value. Right? It would never ask about the OH minus concentration. Right? It would never ask you about the OH minus concentration because we're talking about pH. There is a thing called POH, where it's basically the same idea but with OHs instead of H's, but that's not a thing that we are going to look at. So they're not going to ask you about the OH minus concentration. Can I explain how it's increase again? Sure. Let's wipe this down. If I have, right, going back to what I did before, a pH of 5, actually no, let's make it a little bit easier to see. A pH of 2 becomes a pH of 1. Right, we want to see what H plus concentration change causes this. It starts as 1 times 10 to the -2 and goes to 1 times 10 to the -1. If we take that out of scientific notation, right, a tenth, right, that's 1 over 10, and that's 1 over 100, right, it got 10 times bigger. Right, the steps going down in pH means more acidic, more H plus, and every step is a change of 10. Right, so a decrease of 1 pH, a decrease is more, so it's increasing H plus. It's 1 step, so it's 10 times more. This would be 1 step down. This would be 1 step up. This would be 2 steps down. This would be 2 steps up on the pH scale, right? So this could be, right, let's go 2 to 1, 4 to 5, 6 to 4, 8 to 10. Right, so anytime they're talking about a change in pH, it's a little shortcut for us, right? Every step is 10 times as a 10x change, right? Every step is either 10 times going up or 10 times going down, and the direction, right, decreasing pH is increasing H plus. Decreasing H plus is an increasing pH. Questions, comments, concerns on this one? All right, gonna do one more practice problem with you before I transition us over to tutoring and office hours. Here we have a question that says, what are the products when potassium hydroxide reacts with hydrochloric acid? Here we have a substance and an acid, right? We don't necessarily know off the bat that this is a base. we do know that this is an acid because it tells us it's an acid. This is where reference table K and L are going to come in kind of handy because they're lists of acids and bases. Looking at table K and L are going to give you a little bit of a clue what potassium hydroxide is and what hydrochloric acid is. And this is asking you what goes on the other side of this arrow, right? This whole question is about what things fill in this blank, right? Which is the correct set of choices, which means we need to do a double replacement. Right? We need to take apart these things and put them back together on the other side. To do our double replacement out, we got to take apart our base. We got to take apart our acid. We have to swap the positives or swap the negatives so that we know what happens on the other side. And then we need to put everything back together. Right, crisscrossing all of our numbers back down. Right, they're all ones, so it makes our life really easy. Right, 1, 1, 1, 1, 1, down the line. Which leaves us with the only answer that matches. Right, we did not make KH, so that's definitely not the right answer. We did not make K by itself, so that's definitely not the right answer. We did not make KOH. Right, we started with KOH. We didn't make Cl2. That's not the right answer. Right, our only answer is here. And remember that an acid and a base, right, acid plus base, is always going to make salt and water. Right, always going to make salt and water. So we know that if there's no water, it can't be the right answer. Right. Right, there's no water here, so it can't be D. There's no water here, so it can't be A. There is water in C and D, or sorry, C and B, so that narrows down already to a 50-50. And then we have to check, well, these are not salts, right? Salts are ionic compounds. These are just elements. So it's not this one, no salt. This one has salt and water, so this is the correct answer for us. Questions, comments, or concerns here? Sure. A salt. Remember the definition of the word salt is an ionic compound. So if I'm stuck between B and C, right, a compound is 2 or more elements. This is one element by itself, one element by itself. So these aren't salts. But this KCl is a metal plus a nonmetal, which is the definition of ionic. Right? So K metal, M for metal, nonmetal together makes it an ionic compound, which is what makes it a salt. Right? Remember, salt is more than NaCl. Right? NaCl, right? Table salt is a salt. It is not the salt, right? It's not the only thing that has that name. NaCl is not a special salt, it's just the one that we eat. Right? There's nothing special about it other than that's the one that you eat. So that's why it runs up to the top of your mind way more often. But a salt is an ionic compound. So every single thing we talked about when we were talking about ionic compounds are all salts. Right? KCl, M H2SO4, BAS, right? These are all salts. It's just any ionic compound is a salt. Right. I'm going to stop us here and transition us into office hours and tutoring. So stick around if you want some office hours and tutoring, if you have any specific questions you want answered. I'm going to keep going with this set of practice problems on Monday and Wednesday in our classes, and I'll see you then. Have a great weekend.